just go through classroom workbook. Let us start the session with question number 1. The root of the function f of x equal to x cube plus x minus 1 equal to 0 obtained after first iteration on the application of Newton-Raphson scheme using an initial guess x naught equal to 1. So initial approximation, that is initial guess is x naught. We need to find value of root after first iteration using Newton-Raphson method. So the formula we have is x naught 1 equal to x naught minus f of x naught divided by f dash of x naught. Now what is the f dash of x derivative? 3x square plus 1. Now therefore this is actually x1 equal to x naught minus f of x naught is x naught cube plus x naught minus 1 divided by derivative of this expression 3x naught square plus 1. Now this gives me 3x naught cube plus x naught minus x naught cube minus x naught plus 1 whole divided by 3x naught square plus 1. Now this plus x naught minus x naught will be cancelled. Now therefore this is 2x naught cube plus 1 divided by 3x naught square plus 1. So what is my x1? x1 is 2x naught whole cube plus 1 divided by 3x naught square plus 1. Now here x1 equal to x naught is given as 1. So this is 2 plus 1 divided by 3 plus 1. This is 4. So 3 by 4. So it is 0.75. Therefore the value of x after first iteration using NR method is 0.75. So option C is right. Now this. Now let us go through question number 2. So let me read out. A Newton-Raphson iterative scheme is given by an plus 1 equal to 1 by 5 into 16 minus 12 divided by an, where n is small n is set of natural numbers union 0. So what is his intention to say about n is n starts from 0 onwards, index, initial approximation, next iteration like this. Such a scheme with suitable a naught, that means a naught is a suitable initial approximation. It is suitable. So such a scheme with suitable a naught will, options are given like this: not converge, converge to 1.6, converge to 1.8, converge to 2. See, convergence means whenever continuously you are getting repeated values, that means the Newton-Raphson method has achieved convergence point. That means this is the condition we have for convergence. An plus 1 equal to an for some n. For some n. This is nothing but condition for convergence. So here it is clearly mentioned in the question that suitable a naught. As I mentioned in one of the previous sessions, when you start with initial approximation, Newton-Raphson method always achieves convergence. So in the rest of the options, 1.6 is given, it is 1.8 is given, it is 2 is given. So this is the condition for convergence. So definitely it converges to some point. So option A is wrong, because in the option A it is given as it does not converge, but definitely it converges. So the condition for convergence is an plus 1 equal to an. This implies an plus 1, but an plus 1 is given as this expression. So this is 1 by 5 into 16 minus 12 divided by an equal to an. So therefore multiply this with 5. So it becomes 16 minus 12 by an equal to 5 an. Multiply this with an. So this is 16 an minus 12 equal to 5 an square. So this implies 5 an square minus 16 an plus 12 equal to 0. Now this is a quadratic equation in the variable an. Solve this, you will get two roots and identify which is there in the option. So therefore this is 5n square minus this 16, I can write it as minus 10an minus 6an plus 12 equal to 0. Because the factor of the, when you multiply 5 into 12, you will get 60. So the factorization of 60 is 10 plus 6. So 10 plus 6 is 16, 10 into 6 is 60. So therefore this implies 5n, you can take common, 5n into an minus 2 minus 6 into an minus 2 equal to 0. So group this, you will get 5n minus 6 into an minus 2 equal to 0. So therefore an can be 6 divided by 5, 1.2 or 2. So therefore we got convergence and an must be equal to 2. That means continuously we are getting equal values either at 1.2 or at 2. But in options 1.2 is not given. So let us go for option 2. So therefore this is 2. That means option D is right answer. Just we have applied condition for convergence, because when the initial approximation is suitable, definitely NR method will achieve convergence. Note this point. Now let us move to question number 3. The Newton-Raphson method is used to solve the equation f of x equal to x cube minus, this is my function, f of x equal to x cube minus 5x square plus 6x minus 8 equal to 0. Taking the initial guess as x equal to 5, comma, the solution obtained at the end of first iteration is. So here initial approximation is x naught. Actually initial guess means x naught. So you need to find x1 value using NR method. So this is x naught minus f of x naught divided by f dash of x naught. Now here what is f dash of x derivative? So this is 3x square minus 10x plus 6. 3x square minus 10x plus 6. So here f dash of x naught. So this is f dash of 5. 3 into 5 square. 5 square 25. 25 3 is 75 minus 50 plus 6. So 81 minus 75 and this is 6. This is actually 81 minus 50. So 75 minus 50 is 25, 31. So therefore f dash of 5 is 31, this value. So this is 5 minus, let us calculate f of 5 also, that is f of x. So 5 cube is 125 minus 5 square into 5, 125 plus 6 5s are 30 minus 8. So this is 22. So therefore this is 5 minus divide 22 divided by, this is 31. Now let us simplify this. Here the value of 22 divided by 31. This is 0.7096. So 5 minus 0.7096. Now let us subtract this from 5. So therefore this minus 5. So you will get this as 4.29. So therefore the value of x after first iteration is 4.29. Note this. Now next we move to question number 4. The Newton-Raphson method is used to solve the equation x minus 1 whole square plus x minus 3 equal to 0. The method will fail in the very first iteration if the initial guess is. So very interesting question. They were saying that this method will fail in the very first iteration if the initial guess is. Let us solve at first x1 value. This is actually f of x value. So x minus 1 whole square plus x minus 3. F dash of x equal to 2 into x minus 1 plus 1. So here x1 value is x naught minus f of x naught divided by f dash of x naught. Now here what is the f dash of x naught? This becomes 2 into x naught minus 1 plus 1. Now actually this f dash of x naught is written in the denominator part. When you have 0 in the denominator part, it is undefined quantity. So no matter whatever it is x naught, but if you replace x naught by in the denominator part, in case of first order derivative, if it becomes 0, then the method will fail to get the convergence. Yes or no? Forget about convergence. First of all, you don't get the value of x1. Therefore, you cannot move to next iterative values. Therefore, this must be 0. So to get iteration fails, f dash of x naught should be 0. This implies 2 times x naught minus 1 plus 1 equal to 0. So therefore, this implies 2 times x naught minus 1 equal to minus 1. X naught minus 1 equal to minus 1 by 2. Therefore, the value of x naught equal to 1 minus 1 by 2. This gives me 0.5. Therefore, whenever the initial approximation you choose as 0.5, then f dash of x naught will be 0. In that case, the method will fail in the very first iteration. Therefore, the method fails in the very first iteration if the initial approximation is 0.5. So option B is right answer. Next we discuss question number 5. The solution of the nonlinear equation x cube minus x equal to 0 is to be obtained by NOR method if the initial guess is x equal to 0.5. Then the method converges to which of the following values? So that means they were asking to which of the following values it is getting to be converging. Now let us see how to handle this. At first we try to find x1. Compare x1 with previous value. If it doesn't match, now you go on finding next iterative values, right? So here f of x equal to x cube minus x. F dash of x equal to 3x square minus 1. So therefore here I can go for this. x1 value is x naught minus f of x naught divided by f dash of x naught. So therefore this is x naught minus f of x naught. So this is x naught cube minus x naught. The derivative is 3x naught square minus 1. So therefore this is 3x naught cube minus x1 minus x naught cube plus x naught divided by 3x naught square minus 1. This and this will be cancelled. So therefore this gives me 2x naught cube divided by 3x naught square minus 1. So this is my x1 value. It is 2x naught cube divided by 3x naught square minus 1. Now let us find x1 value by using x naught 0.5. This is x naught initial approximation. So this is 2 times this is 0.5 whole cube. So I think this is 0.125. So 5 into 5 into 5, 125 into 1000. So 0.125 divided by 3 into zero point 0.5 whole square. Zero point 0.5 whole square is 0.25. So this is 0.75 minus 1. Let us simplify this. So the values are like this. 0.5 into 0.5 equal to 0.25 into 3, that is equal to 0.75 minus 1. This gives me minus 0.25. So 2 into this is 0.125 divided by this is minus 0.25. Let us cross check this. So this is 2 into 0.5 whole cube. So this is 0.5 into 0.5 into 0.5, 0.125 into 2. Yeah, this is 0.25. This value is 0.25. The total expression gives me 0.25 divided by this is minus 0.25. So this gives me minus 1. So x1 is minus 1. Current value is not matching with the previous value. Current value is not matching with previous value. So let us calculate x2 value. Using this expression, x2 becomes 2x1 cube divided by 3x1 square minus 1. So therefore replace x1 by minus 1. This gives minus 2 by 2. So it is again minus 1. So previous x1 value is minus 1. Current value is minus 1. Therefore, in this case, we got x2 equal to x1. Therefore, it converges to minus 1. So therefore, option A is right answer. Note this. In question number 6. The Newton-Raphson iteration xn plus 1 equal to half into xn plus r divided by xn can be used to compute square of r, reciprocal of r, square root of r, logarithm of r. Apply condition for convergence xn plus 1 equal to xn. So this xn plus 1 is to be replaced by this expression half into xn plus r divided by xn equal to xn. So therefore this value gives me xn square, or I can do like this. This value gives me xn plus r by xn equal to 2xn. So therefore xn equal to r by xn. Xn square equal to r. So therefore xn equal to square root of r. Therefore this is a recurrence relation by using Newton-Raphson to get the square root of a number r. So therefore option C is right answer. Just we have applied condition for convergence, that is xn plus 1 equal to xn, and we got xn as square root of r. Next we discuss question number 7. It is known that the two roots of non-linear equation, this is x cube minus 6x square plus 11x minus 6 equal to 0 are 1 and 3. Then the third root will be In option A, j is given, complex number. Option B, minus j. If j is right answer, its complex conjugate becomes root. In that case, third degree equation will have 4 roots. How it is possible? Therefore, option A and B are wrong. So answer can be either 2 or 4. It is a third degree equation. You will have 3 roots. Already 2 roots are given. They were asking to find third root. Therefore, this expression x cube minus 6x square plus 11x minus 6 can be factorized like this. X minus 1 into x minus 3 into. Assume that the third root is k. So therefore, this is the factorization of this third degree polynomial. Assume that k is third root. So apply constant coefficients on both sides. Compare constant coefficients. So when you compare constant coefficient, here it is minus 6. Here constant coefficient is minus 1 into minus 3 into minus k. So minus 3k. Therefore, k value becomes 2. So the third root is k equal to 2. So option C is right answer. Now we discuss question number 8. The polynomial p of x equal to x power 5 plus x plus 2 has option A, all real roots, 3 real and 2 complex roots, 1 real and 4 complex roots, all complex roots. All complex roots cannot be possible. Why? It is a fifth degree polynomial expression. When you take a fifth degree polynomial expression, generally we have 5 roots. Now the problem is how many roots are real and how many roots are complex. So question is related to this. All cannot be complex because the number of complex roots of any polynomial expression is always even. So therefore, if at all this has a complex roots, in the worst case, it will be having 4 complex roots, maximum case. So the number of complex roots of any fifth degree equation will be in the worst case 4. But remaining must be real root. So all complex roots are not possible. So option D is a wrong option. So it may have 3 real, 2 complex roots, 1 real, 4 complex roots, or all real roots. So let us hope for this. Now here coefficient of x power 5 is 1. Coefficient of x is 1. It is 2. So since it is a fifth odd degree polynomial, it must have at least 1 real root. At least 1 real root. So let us try for this real root. All coefficients are positive only. Whenever all coefficients are positive, such polynomials do not have positive real roots as positive real roots. Because when x is replaced by positive real number, positive whole power 5, positive, plus 2, how it becomes 0? Therefore, when there is a polynomial expression in which all coefficients are positive, such expressions do not have positive real roots. So there is no chance to get positive real roots. No chance to get positive real root. So 0, there is a chance to get 0. But p of 0 equal to, this is not equal to 0. Therefore 0 cannot be root. But we know that this is an odd degree polynomial. So it must have at least 1 real root. Why it is so? Degree is 5. It will have 5 roots. But if it has complex roots, at most it will have 4 complex roots. So rest will be real. So there is no chance to get positive real root, no chance to get 0 as real root. So definitely it will have negative real roots. Let us try for this. It clearly says that p of minus 1 is minus 1 whole power 5 plus minus 1 plus 2. This will be 0. Therefore minus 1 is a root of p of x equal to 0. Minus 1 is a root of p of x equal to 0. So this is one real root. Next I try for another real roots. If I try for p of minus 2, this becomes minus 2 whole power 5 plus minus 2 plus 2. This is not equal to 0. Similarly, when you replace x by any negative number, odd power is there, odd power. X power 5 plus x becomes a negative number with minus sign. So that should not be equal to plus 2. Therefore, minus 1 is the only real root. P of minus 3 cannot be 0. P of minus 4 cannot be 0. Why it is so? When you replace x by negative number, x power 5 is negative. X is negative. X power plus 5x is x power 5 plus x will be again negative number. But that should not be equal to plus 2 in terms of magnitude. Therefore, this cannot be 0 when you replace x by any real number other than minus 1. So, minus 1 is the only real root. But if minus 1 repeats 3 times, if minus 1 is a root of this equation with algebraic multiplicity of 5, then how to proceed this? Okay, let us see. Can I write like this? Suppose if P of x equal to, that is P of x means this, x power 5 plus x plus 2 equal to x plus 1 whole power 5. So is it true? Actually, because when you write like this, that means minus 1 is the root of this equation. Then right side expression will have x power 4 terms, x cube terms. But here we don't have x power 5 like this. So therefore, in this case, this is a wrong statement, which is absurd. So if x power 5 plus x plus 2 equal to this, then here you will get x power 4 terms. Here you won't get x power 4 terms. So therefore, this is wrong answer. Therefore, all real roots is again a wrong option. All complex will be again wrong option. Let us try for 1 real and 3 complex roots. So 1 real means, I mean, this is 2 real and 3 complex roots. But it is given as 3 real and 2 complex roots. So therefore, this is 3 real and 2 complex roots. That is if x power 5 plus x plus 2 equal to real root is only minus 1. If I go in favor of option number this 3 real and 2 complex, then this becomes x plus 1 whole cube. Already degree is 5. It is written as 3. So next must be second degree polynomial expression. So this is ax square plus bx plus c. So in this case, what will happen is the value of a becomes 1. But there is a chance to get either b or c takes multiple values. See, I am verifying each option because this is a polynomial expression. Odd degree polynomial, all complex roots are not possible. So option D will be violated. Positive real roots are not possible. 0 is not possible. Negative roots are possible. That we got it as minus 1. Now my doubt is, if minus 1 repeats 5 times, if this happens, then you will get x power 4 terms, x cube terms on right side. But here we don't have those values on the LHS. So therefore, this expression cannot be equal to this. It's a wrong statement. So I wrote it as absurd or simply contradiction. I can use contradiction also. Contradiction means you cannot write like this. So all real roots are not possible. Suppose if it has 3 real and 2 complex, then I can represent like this. X power 5 plus x plus 2 equal to this. Because if minus 1 is a root repeating 3 times, I can write it as x plus 1 whole cube. Into this is a 5th degree polynomial, already degree 3 is covered. So next must be a second degree polynomial expression. So which can be in the form ax square plus bx plus c. When you equate terms on LHS and RHS, a will be 1 only. That's clear. Because ax square into x cube, ax power 5 equal to x power 5, a becomes 1. But either b or c takes multiple values. Therefore, this is also a contradiction statement. Therefore, 3 real and 2 complex roots is also a wrong option. Therefore, finally, it has 1 real and 2 complex roots. 1 real and 4 complex roots. Therefore, it is option number C. Option C is right answer. Very helpful question. Note this. Next question. The bisection method is applied to compute a root of the function. This is question number 9. The bisection method is applied To compute a root of the function f of x equal to x power 4 minus x cube minus x square minus 4 in the interval closed interval 1 comma 9. The method converges to a solution after blank number of iterations. So here number of iterations is 1, 3 or 5 or 7. So you try to, this is a polynomial expression, it is continuous in this interval. To apply bisection method, I need to apply intermediate value theorem. So here f of 1 is, I think this is 1 minus 1 minus 1 minus 4. It is negative expression. So definitely f of 9 is a positive expression. So root belongs to open interval 1 comma 9. Therefore here the first approximation x1 equal to 1 plus 9 divided by 2, it is 5. So therefore divide this interval into two subinterval at its midpoint. It is 1 comma 5 or 5 comma 9. So that means root may belong to either this or this. Now what is f of 5? This is 5 power 4 minus 5 cube minus 5 square minus 4. I think this is a positive quantity. So you can see f of 1 is less than 0, f of 5 greater than 0. So therefore root belongs to, root lies in open interval 1 comma 5. Therefore the next approximation value, iteration value is x2 equal to midpoint of this. So it is 3. Now calculate f of 3. This is 3 power 4 minus 3 cube minus 3 square minus 4. It is also positive. So divide this into two equal subintervals at its midpoint. 1 comma 3, 3 comma 5. F of 3 is greater than 0. F of 1 less than 0. So therefore root lies in open interval 1 comma 3. So x3 value is midpoint of this. It is 2. So calculate f of x3, you get 0. F of 2 power 4 minus 2 cube minus 2 square minus 4 is 0. So we got convergence in third iteration. Just we have applied intermediate value theorem 3 times. First, it is applicable in open interval 1 comma 9. Next, it is applicable in this interval. Next, it is applicable in this interval. Here x1 equal to this, x2 equal to this, x3 in this case. x1 you will get in this iteration, x2 in this interval, x3 in this interval. So f of x3 is 0. That means that we got the convergence in third iteration. Okay. So option B is right answer. Thank you so much. The session is over.